Hey everyone, in this video we will understand one of the searching algorithm. The name of the searching algorithm is binary search. So we will understand what is binary search and how this algorithm actually works. And we will also implement this binary search using the iterative method. And at last I will tell you what is the time complexity and the space complexity of our iterative solution. Okay, in the previous video I have already explained about the linear search and I have implemented that using the iterative and the recursive method. So if you have not watched that video, you can find the link of that video in the video description below or in the design and analysis algorithm playlist. Okay, so do watch them. Now let's start with the binary search searching algorithm. So what is binary search? Basically binary search is a searching algorithm. Okay, and basically if you are given a lot of numbers, okay, a collection of numbers, and you want to search or find whether a particular element is present in that collection of numbers or not, then you can use the binary search. And now this is very important. This binary search algorithm can be implemented only on the sorted array. Array means collection. Okay, so if you are given the numbers in a sorted fashion, then only you can apply this binary search algorithm. Okay, you cannot apply this binary search directly on the unsorted array. Okay, so sorted means your elements can be in the increasing order or they can be in the decreasing order. Okay, or there can be some repeated element also in the sorted array. Okay, that also works fine. Okay, so here are some examples. So here you can see we are given this array or collection of numbers which are in the increasing order, right? Now we want to find whether 10 is present in this array or not. Okay, so this 10 is called as key. Okay, so 10 is present in this array. Here you can see, right? So your answer should come as 10 is present. If you are given this array, okay, so this array is actually in the non-decreasing order. Okay, or is in simple sense you can say in the increasing order. Non-decreasing means all the elements are in the increasing order, but some of the elements they are also in the repeated fashion. Okay, so we want to search 24. So 24 is present in this array. So your answer should be 24 is present. Now in this array, we want to find 9. And 9 is actually not present in this array, right? So your answer should come as 9 is not present. Now let's see how binary search algo works. Okay, and how we can actually solve our problem of searching a given number in a sorted array using the binary search. Now before starting with the binary search, let's play a game. The game is read my mind. So John says to you, okay, you are Aman. John says to you that, hey Aman, let's play a game. And the game is, I will guess a number or I will think a number between 1 to 10 in my mind. And you have to tell me what is the number that I have thought in my mind. Okay, so you have to read my mind. Now John says there are some rules of this game, and the rules are you can actually ask me simple one question, whether the number that you have guessed in your mind, okay, it is greater than some number or lesser than some number. Okay, only these questions you can ask, and I can only say yes and no. Okay, I will not tell you anything. So at last you have to tell that what number John has actually thought in his mind. Okay, so let's start with the game. Let's say John has thought a number 9, and you have to tell at the end of the game that number is 9. Okay, so you started the game and you said, okay, let's do the half of these numbers. Okay, you applied this technique. You said, okay, 1 plus 10 by 2 is what? It is 11 by 2, that is 5.5. And you said, okay, I will just take this integer part, 5. Now you ask the John whether the number is 5. John says no. Then you ask to John whether your number is greater than 5. So John says yes, because 9 is actually greater than 5. Okay, so you said, okay, number is not 5, so it can be either 6, 7, 8, 9, 10. Okay, so now in the next turn, what you will do, you say, okay, I will do the half of 6 and 10. Okay, so it is like 16 by 2, it is 8. Now you ask to John whether the number is 8. John says no. Then you ask to John whether your number is greater than 8. So John says yes. So you thought, okay, number is not 8. Okay, so it can be maybe 9 or 10. So now you do the half of 9 and 10. So half of 9 and 10 is 9.5. You take the integer part, you said 9. Okay, now you ask to John whether the number is 9. John says yes, number is 9. So you won the game, right? You are able to read the mind of the John. Okay, so now let's start with the binary search. So basically binary search is similar to this only. Okay, actually you have applied the binary search technique. Maybe in childhood you may not be knowing the terminology okay, but this is actually the binary search. Okay, now let's see how we can apply the binary search, okay, for our question. Okay, let's say you are given this array which has total 18 elements. So array size is 18, okay, 0 to 17 indexes, okay, and you have to search 82. Okay, so in this sorted array, is 82 present? Yes, 82 is here, right? So that means your answer should be 82 is present. Okay, so now let's see how binary search will be applied. Okay, so what actually binary search do? It will first point to two indexes, that is 0 and 17. Okay, so let's say we take two variables, okay, that is low and high. Okay, so low is basically at the 0th index and high is at the last index, that is 17. Okay, now what will happen? Now binary search says I will actually do the half of this range. Okay, 0 to 17. Okay, this is the range and I will do the half. Okay, I will find the midpoint of this range. Okay, so basically midpoint of 0 and 17 is 0 plus 17 by 2. So it will be 8.5. Now binary search say I will just take the integer part. Okay, so actually you are taking the floor of this number 8.5. Okay, floor will be 8. Okay, so now this will be called as the midpoint of this range 0 to 17. Okay, and at midpoint this 45 is present. Okay, now the next step that the binary search say, okay, now let's see whether 82 is equal to this 45 or not. Okay, whether 82 is equal to your mid number or not. You will say no, 82 is not equal to 45. So you say, okay, I will continue with my binary search. Now what will happen, as this is the sorted array, so binary search says, okay, 82 can be greater than 45 only. Now binary search says, okay, as you have to find 82, 82 is not here, so 82 can only be on this side. Why? Because this is a sorted array, right? So actually you will move to your right side. Okay, this side. Okay, so what you will do, you will say, okay, now 82 is not equal to this 8th index element, so I will start searching from this point. Okay, from index number 9 to 17. So you will shift your low pointer or low index variable to the 9. Now your low index has come to the 9. Okay, so low is 9 and high is actually 17. Okay, so that means you are not checking these element. Okay, you will not check these element. Why? Because 82 can only be present on this side. Okay, it cannot be present here. Okay, so you have just come to at 9th index. Okay, now you will just search from 9th index to the 17th index only. Okay, now again you find the midpoint of this low and high. Okay, so 9 plus 17, this 9 plus 17 by 2, this will give me 26 by 2, that is 13, right? So this 13 is my new midpoint, okay, between this range. Now you will check whether 82 is equal to this mid element, that is 65. You will say no. Now you will say, okay, so which side I should move, whether I should move to the right side of 65 or I should move to the left side of 65. So you will say this is a increasing sorted array, right? So 82 is actually greater than 65. So that means 82 will be on the, you can say, right side. So what you will do, you will say now my range will be from 14 to 17. Okay, so that means your low pointer will be shifted to this point. So now you have a new range 14 to 17. Okay, now you will search your number between 14, 15, 16 and 17 using again the binary search. So binary search say again find the midpoint of this new range. Okay, so you will do 14 plus 17 by 2. So 14 plus 17 by 2 is basically 15 if you take the integer part, right? So that means this 15 is your new midpoint. Now you check your key element with this new mid element. Okay, so new mid element is a of 15, that is 82. So 82 is equal to your key element. That means your key is found, your key is present. Okay, so now you will stop your binary search algorithm. So this is how your binary search algorithm actually works. So in this whole example, your actually low pointer was going in this side, right? Now let's see the another example, okay, in which low and high both will change. Let's say you have to find the number 55 and 55 is basically present in this array here. Okay, so your output should be yes, 55 is present. So again you will take two pointers, low and high. Okay, so you will find the midpoint of this low and high. Okay, so midpoint will be 8. Okay, so your midpoint is this 8. Now you will check whether your key element is equal to this mid element. So you will say no, 55 is not equal to 45. So you will do what? Now you will see where I should move. whether I should move to this side or either I should move to this side. So you said, okay, I have to search 55, and this is an increasing sorted array. We will say 55 is greater than 45, so it can basically on the this right side, right? So you will say, okay, I will make my range from 0 to this 9. Okay, that is, I will shift my low pointer to this 9th position, that is mid plus 1. Okay, so you say, okay, now my low pointer will come at the 9th index. Okay, now you again do the same task. You find the midpoint of this low and high range. Okay, so midpoint will be 13. So you said, okay, new mid is 13. Now again you check whether 55 is equal to this 65. Okay, this new mid element, you will say no. Okay, now again you will see if it is not equal to 55. Okay, so where should I move? Okay, so that I can search 55. So basically you will say 55 is lesser than 65, right? That means 55 will be on this left side of 65, right? So you will say currently my range is this one. I got this mid element here, my key was not present. Okay, that means my range can be this one, from low to this. Okay, that is, I can search my element now only between 9, 10, 11, 12. I need not to search my element between 14, 15, 16 and 17, because my key element, that is 55, can only be present only this side, not only this side, right? Okay, so you leave this numbers. Okay, you leave these numbers. You will not waste your time in scanning these numbers. Okay, so now your high will change, right? Your high shifted to 12. Now this is your new range. Okay, now you again find the midpoint. So midpoint of 9 and 12 will be 10, right? So this is the new midpoint. So now you will check again that 55 is equal to this new mid element. You will say yes. So now again you find the midpoint of 9 and 12. So it is basically 10. Now you check whether your 55 is equal to this 55, that is the 10th element. You will say yes. So that means your key is present, 55 is present, right? So here your high was also changed, right? From 17 to 12, and your low is also changing, right? So depending on the input type, okay, your low and high, they can change, okay, time to time. And lastly, if you want to find a number which is actually not present in this array, let's say you want to find 53, and 53 is actually not present in this array. So your answer should be that your element 53 is not present in this array. So then how it will work? So basically all the steps will remain same, okay, till this point. Okay, so basically when you will be at the 10th position, you will again check whether your key element is equal to this mid element. You will say no, right? Now you will see, okay, where should I search now 53? Whether I should move to the left side or right side of 55? So you will say 53. Okay, it is actually lesser than 55. So that means your element will be on the left side. Okay, so now your current range is this 9 to 12. Okay, and you try to find the element at the 10th position. It was not present. So you will shift your high to this position. Okay, that is mid minus 1. Okay, again and again you are doing mid minus 1. Here also you did the same thing, mid minus 1. Mid was 13, so you shifted to 13 minus 1, 12, right? So your now low and high, they will both point to 9th position. Low and high both are 9th position. Now you find the midpoint of this position, low and high, 9 plus 9 by 2, it is again 9. So now you checked whether your 53 is equal to this 9th position element. You said no, 53 is not equal to 52. So you said, okay, then where should I move? So basically low and high are pointing at the 9th position. Okay, and your 53 is not equal to this 52, and 53 is basically greater than 52. That means your 53 can be on the this side, right? So basically I have shown here. Okay, basically I have shown here. So now what will happen? 53 can only be on this side. So now you have to change your low variable, right? Low pointer should be changed. So low pointer will now shift to this, that is mid plus 1. Okay, currently this is mid also. Okay, so low will be changed to mid plus 1, that is low will come at the 10th index and high will remain at the 9th. Now here we have got a situation. What is the situation? Now low has become greater than high, right? So when this condition will be reached now, that means your key is not present, right? Basically you should terminate your binary search here. Okay, and it will just say key is not present. Okay, so I hope you have understood that how this binary search algo is working. Okay, now let's see the algorithm for this binary search. Okay, so here is our solution for the binary search, and this is the iterative code. Okay, so basically this is the array which is having 18 elements. Okay, so this is the function. Okay, and this function is basically taking the input. Okay, 3 inputs: array, the number of elements in the array, that is 18, size of the array, and the key element. And this is basically a pseudo code. Okay, so here first what we have to do, we have to actually set the low and the high pointers. Okay, or you can say these are the simple variables. Okay, the low is pointing to the 0th index and high is pointing to the last index. So for n equal to 18, this is actually n minus 1. Okay, now we have to do some repeated tasks. So these are the repeated tasks, and these repeated tasks should be done for how much time? They should be done till low is lesser than equal to high, right? Okay, as I have told you, okay, when we were searching for 53, okay, we reached to a condition where low was greater than high. So when low will become greater than high, then that means your element or key is not present. Okay, but till the point low will be equal to high or low will be lesser than high, then we can do this repeated task again and again. Okay, there is a possibility that our element will be present. Okay, let's see. So basically currently low is 0, high is n minus 1. So what I will do, first I will find the midpoint of this range, low to high. So low plus high by 2. Okay, and then I will find the midpoint. Okay, or mid index. Then I will check whether my key is present at this mid index or not. If my key is present at the mid index, then I will simply return true. Okay, and my program will actually exit, or you can say my this function will exit and it will return to the caller. Okay, let's say main function has called this binary search, so true will be returned to the main. Okay, and main will say, okay, if I have got true from this binary search, that means your key was present. Okay, now let's say if your key is not equal to a of mid, then what I was doing, then I was taking the decision whether I should move to the, you can say, right side of the mid element or to the left side of the element, right? So I am doing that thing. If my key element that I want to search, it is greater than, okay, you can say mid position, then I was going in this side, right? That means I was shifting my low pointer to this, that is mid plus 1, right? I was shifting my low pointer to mid plus 1, and then I say, okay, low will be mid plus 1. But if key is lesser than a of mid, okay, let's say mid is some point, okay, and my key element that I want to search, it is lesser than this particular element, then I will say I have to move to the left side. That means then my high pointer will be shifted. Okay, and where my high pointer should come, it should actually be at the mid minus 1 position, right? So that's why I'm saying high equal to mid minus 1. Okay, so here we are changing the either low variable or the high variable. Okay, any one will be changed. Okay, and accordingly here low and high will come closer to each other. Okay, and accordingly again I will find the midpoint. Again I will check at the new midpoint whether my key is equal to the this new index element. If yes, then I will say okay, true. Okay, exit this binary search. Otherwise I will keep on changing low and high again and again. Okay, and when my low will be greater than high, then I will simply come out. Okay, and that means my key element will not be present, so I am returning false. That means key is not present. Okay, so basically if I am coming here, that means I have not encountered this statement. Okay, and if I have not encountered this statement, that means this condition will be never be true, and this condition is never be true. That means my element was not present in the this sorted array, right? That means I have come here, so simply return false. That means key is not present. So basically you can apply this algorithm for this 55 element. You want to search 55. Okay, so this is my low. Okay, I'm just writing L and you can say high. Okay, low and high. Then I find the, you can say 0 is less than equal to 17. I say yes, it is lesser than 17. Then I find the midpoint. Midpoint is 8. Okay, then I say okay, my key element, that is 55, is equal to a of 8. I say no. Then I decided whether I should move to the, you can say, this left side, or sorry, right side, or you can say this side. Then so I check the key element with the midpoint. Okay, based on that I decided. So I say okay, my 55 is actually greater than 45. Okay, so I have to change low. So I changed low, and low was coming to at this position, right? because my element has already been checked with this 8 index. So I need not to shift this low to this midpoint. Okay, I can just carefully, or I can just safely shift this low to the mid plus 1 position. So mid plus 1. Now I will check between only this range. I will not check all these elements. Okay, so now again I will come here and I will say, okay, 9 is less than 17. Okay, 9 is less than 17. So now I will find the midpoint, that is 13. Okay, 13. Now 13th element is this. Okay, and I will check whether my 55 is equal to 65. Okay, so that means no. So I will change now low or high. I said, okay, my 55 is actually lesser than 65. So I should move to this side. So my high pointer should come here, right? So that means here you can see my key is actually lesser than A of mid. Okay, lesser than 65. So I'm changing high. High is coming to mid minus 1. Okay, then again this same thing will work. Okay, and now high is 12. So I will search between 9 and 12, and again I can do the same work. Okay, so my new index will be 10. Okay, this mid. Okay, and I will check whether 55 is equal to this A of 10. I will say yes, it is equal. So basically I will return true. So now my algo will return to the main function. Okay, if main function is called the binary search. Okay, and main will say, okay, your key is present. So I hope you have understood that how this binary search algo is working. Okay, now at last let's find the time complexity and the space complexity for this binary search iterative code. So basically for finding the time complexity, I should know that how many steps this binary search algo is running. Okay, how many steps it is taking, okay, to execute itself. So basically if you carefully observe in this code, what I am doing is I am scanning a particular range every time, and I am leaving some of the element. I'm not checking those elements. For example, initially I checked for 0 and 17, right? For example, initially I checked between the range 0 to 17. Okay, and then I find the midpoint. Instead of linearly searching all the element, I just said, okay, find the midpoint. Okay, and I find the midpoint this, and then I first check with this element. Okay, I first check with this element, which can be done in just 1 unit amount of time, right? And then I decided very carefully that this is a sorted array, so where I should move. Okay, what can be the probable range in which my element can be found. So for 55 you decided that you should move to this side, right? That means these elements are of no use to be scanned. Okay, you can just leave these elements. So basically you left how many elements? You leave, you can say n by 2 element. If this whole range is, you can say, n element. Okay, so these are, you can say, nearly n by 2 element. So you basically you left n by 2 element, and you are only checking remaining n by 2 element, right? And again what you did is you said, okay, this is my new range, low is 9 and high is 17. So now you check between this and you find the midpoint, and you check just in 1 unit amount of time whether my 55 is equal to this. You said no. Then you said, okay, now what should be the next range in which I should search? So you say, okay, 55 will be lesser than 65. So you just see this range, right? You can safely leave these elements, that is 14, 15, 16, 17. You need not to check your key element with these elements. Okay, so again what you did, you have the element. The total, how many elements were there? From 9 to 17 you have total 9 elements, right? And now you say, okay, you are just checking 1, 2, 3, 4. That is only 4 elements. So 9 by 2 is actually nearly 4.5. So basically you left half of the element and you are just checking 4 elements. Okay, so at each point of time what you are doing, you are actually leaving half of the element and you are checking remaining element. So some of the element will never be checked, right? Will never be checked. So that means you will be able to get your answer whether your key is present or not in lesser number of steps. So basically here if you see, your 55 was found in how many steps? So first you did this step 1, then you again find the midpoint between this. Okay, then you find the midpoint between this, and then you were able to find your element. That is, in 3 steps you were able to find your number, that is, it is present. Okay, but if you have applied the linear search on this code, then in how many steps it will tell whether your 55 is present? So basically it will check from 0 to 10, that is 11 time it will check, and in 11th time it will tell you whether your element is present in the array or not. Okay, even if you are checking the last element, your linear search will take actually 18 comparison, okay, nearly 18 comparison to search your number, okay, that 92 is present. But if you apply binary search, you will see you will take lesser number of steps, okay, to search your last element also. How many number of steps this algo is running? Initially you had the n numbers that you want to scan, okay, and after that you said, okay, I will just check n by 2 element, okay, that is only this part of the element, let's say, okay. Then you said, okay, after just finding the midpoint, then you said, okay, I will just check only remaining half element of this current element, that is n by 2 element was there. Then you said, okay, I will just check n by 4 element only, right? Okay, and then you keep on doing this thing, half of this n by 4, that is n by 8, okay, and then at last what will happen, you will be left with only one element, right? And then you can just check in unit amount of time whether your key element is equal to that particular single element or not, and after that your binary search algo will stop, okay, either it will say key is present equal to that element or it will not be present, okay. So basically how many number of steps are there? So basically in the first step you did this range as half, okay, you make this range half. In the second step you make this range as n by 4 and you check only these elements. In the third step you actually check only these elements. So basically if you see in the step number 1, you are actually having only n by 2 element, which can be written as n upon 2 to the power 1. In the second step you have only n by 4 element, that is n by 2 to the power 2. In the third step you have only n by 2 to the power 3 element, okay, 2 to the power 3 is 8. So in some kth step, how many element you will be left with to search? In the kth step you will have only n upon 2 to the power k element in which you have to search for your number, okay. And when this n by 2 upon something will reach to 1, right, only single element will be there, then you will actually can stop, okay, or nearly you can stop, okay. Basically when this thing will reduce to, or this will become 1, okay, this whole will become 1, then you will stop, okay. Now you have to find how many number of steps are there, okay, that is you have to find the value of k. So how you can find the value of k? So this whole is basically equal to, you can say n equal to this 2k can be multiplied with this, n equal to 2k. Now I have to find the value of k. So what I can do, I can take the log of this, okay, and I can just simply solve them, okay. Now this can simply be written as k. K can be taken here. So by simply solving it, we get k equal to log 2n. That means these total steps that will be taken to run this binary search algo will be log n base 2. Each time we are doing the half and then we are going in particular range, okay, we are shifting low and high. So how many times this loop will run? It will run for k, that is log 2n times only, okay. And in each of the step we are actually finding the mid number, okay, and this can be done in O of 1 time, right, or you can say in constant amount of time. Then we are doing the comparison. This can be done in again constant time, right, and then again we are checking this and this. Again this comparison can be done in O1 time and O1 time. So basically in each of the call we are doing constant amount of work, and this is taking how much time? Constant time, right. Total number of steps is log 2n into unit amount of time, you can take 1, okay, or constant time. So this is basically equal to order of log 2n only. So this is the time complexity of the binary search algo. Now what is the space complexity of this code? So basically other than your original array, okay, we are not taking any other array, okay, which is, you can say we are not taking any extra space which is dependent on your input, okay, which is dependent on n, okay. Basically we have just taken the simple variable low and high, okay, which actually takes the constant amount of space. These are like 4 byte integers, okay, mid is also 4 byte integer, okay. So you know, to find the space complexity, okay, this constant will be of no use, okay. So basically we have not taken any extra space, so space complexity will be equal to order of 1, that is the constant space. So that's all for this video. In the next video we will understand how we can implement the binary search using the recursive code, and we will also understand that what is the problem in this line of code, that is we are finding the mid as low plus high by 2. There is a problem in this. Okay, so we will understand what is the problem in the next video. So if you have any comment, question, suggestion, please write down into the comment box and I will surely answer. So do like, comment, share this video, and please subscribe the channel and press the bell icon for the notification of the video. See you in the next video. Till then, goodbye.